In this section, we'll be concentrating on quadratic, cubic, and absolute value functions. Again, you can use a table of values to graph any of these. So the thing that you need to do, though, is you need to concentrate for each of these on a central value. In the case of the absolute value function and quadratic function, that'll represent the vertex of the graph. In a cubic function, there is a central value. It's not so much called a vertex, but we can use the same idea. The first thing that you need to do is take a look at the inside of those parentheses and ask yourself what x value would make that inside of the parentheses equal to 0. And so x plus 3 equals 0. X equals -3 is going to be our central value. So when I make my table of values, I'm going to put -3 here in the center for the x value, and the y values are x plus 3 squared. I'm sorry, cubed. Make sure I get the exponent right. All right, so I'm going to use -3 as a central value, and then I'm going to choose some values that are smaller and some values that are rather, actually, those values are larger, and these values are smaller. It doesn't really matter what order you go, as long as you choose a few that are larger and a few that are smaller. All right, so let's use the number 0 to start with. If x is equal to 0, 0 plus 3 is 3, and 3 cubed is 27. So I've got 0, 27, which I can't graph on that grid. Let's try -1. -1 plus 3 is 2. 2 cubed is 8. I can graph that one. -1, 8. Choosing -2. -2 plus 3 is 1. 1 cubed is 1. And so -2, 1 is another point that I can graph. Choosing -3. -3 plus 3 is 0. 0 cubed is 0. And so I can graph the point -3, 0. Choosing -4, we get -1 cubed, which is -1. Again, I can graph -4, -1. Choosing -5, we get -2 cubed, which is -8. -5, -8. And -6 plus 3 gives me -3. Cubed is -27. That one's off the graph. I cannot graph that one. That makes me feel like I've got all the points that have integer coordinates that are on this grid. And now we're going to connect them with a nice smooth graph. That one looks like a water slide. That's, if you remember, that's what a cubic function looks like. Next, we'll take a look at an absolute value function. So this one can be graphed using that same strategy. I'm going to think about the inside of the grouping here, which is inside of the absolute value, and I'm going to ask myself, what value is it that makes that inside x minus 6 equal to 0? And so that would give me x equals 6 as my central value for my table of values. So let's use 6 in the center, and then we'll use some smaller values, 5, 4, 3. That should probably be enough. 7, 8, 9. Hopefully that will be enough. All right, and then the y values are equal to 1 minus the absolute value of x minus 6. And so when I put in 3 in for x, then I've got 1 minus the absolute value of 3 minus 6, which is -3. And so the absolute value of that is +3. 1 minus 3 is -2. I can graph the point 3, -2. And then putting in a 4, 1 minus 4 minus 6 is -2. So 1 minus the absolute value of 2 is 1 minus 2, which is -1. Putting in 5, that's going to give us the absolute value of -1. That's 1 minus 1, which is 0. And when we put in 6, we've got 1 minus the absolute value of 0, and that's going to give me 1. And I've graphed the points wrong, so bear with me here. that was supposed to be 3 comma negative 2, and then 4 comma negative 1, 5 comma 0, 6 comma 1. Okay, now I'm caught up, and let's put the number 7 in for x. That's going to give me 1 minus the absolute value of 1, which is 0. So 7 comma 0. You notice the graph's turning around now. And then 1 minus, when we put in 8, that's the absolute value of 2. 1 minus 2 is negative 1. So 8 comma negative 1. And when we plug in 9, we're going to get 1 minus the absolute value of 3, which is negative 2. All right, so now the only thing left to do is, now that I see that V shape, and that's what happens at the central value, right? It's linear on both sides, but it turns in a different direction. So I'm just going to continue that left portion to plot all the points with integer coordinates, and then we can go ahead and connect and put our arrows on the end to indicate that the graph still continues beyond the grid. And now we'll examine a quadratic, or a function with a square in it. So again, we have this parentheses x plus 4. So I'm thinking about what makes the inside, what makes the inside of that parentheses equal to 0. So if x plus 4 is equal to 0, then x equals negative 4 is going to be my central value. So let's make a table. And I'm going to put negative 4 in the center. We'll need negative 5, negative 6, negative 7. Let's try that. And then negative 3, negative 2, negative 1. We'll see if that gives us enough points. And the y values are equal to x plus 4 squared. So negative 7 plus 4 is negative 3, and negative 3 squared is 9. I can graph the point negative 7 comma 9. So that's there. And when x is negative 6, we get negative 6 plus 4, which is negative 2. Squared is 4. That's negative 6 comma 4. Can graph that one too. And negative 5 plus 4 is negative 1. When I square that, I get 1. So negative 5 comma 1. Negative 4 plus 4 is 0. 0 squared is 0. So negative 4 comma 0. And negative 3 plus 4 is 1. So that gives me 1 squared, which is 1. Negative 2 plus 4 is 2. 2 squared is 4. And negative 1 plus 4 is 3. 3 squared is 9. And I think you can see where this is going. The next value that we would get on the y column would be 16, and that would be too big to graph. So that's enough. We may have to do more points if there are more points that fit on the graph, depending upon how this function is transformed. Let's do one more. This one is another absolute value function, but this time the inside of the absolute value is just x. So if we set that equal to 0, then that gives us x equals 0 as our central value. So I'm just going to put x equals 0 as my central value and graph a few negatives and then a few positives. And our y value is the absolute value of x plus 6. The absolute value of negative 3 is 3. 3 plus 6 is 9. So negative 3 comma 9. The absolute value of negative 2 is 2. 2 plus 6 is 8. I can graph that. The absolute value of negative 1 is 1. 1 plus 6 is 7. I can graph that. The absolute value of 0 is 0. 0 plus 6 is 6. The absolute value of 1 is 1. 1 plus 6 is 7. And I think you can see where this is going, right? It has turned now. The V has turned. So this next section is going to go upward. And now that we've graphed all the points with integer coordinates that fall on the grid, we can go ahead and connect with straight lines. So the absolute value is this V shape. The quadratic is with a square is a parabola. And the water slide is the shape of the cubic, just so that you know what shape you should be looking for when you're making your table of values. That's it for that section.